Hello guys, welcome back in today's session. Uh, I'm Professor Fayyaz Karagi from Department of Mechanical Engineering with continuation with various topic regarding helical gear. All the theoretical and derivation part is over. So today we are taking some numericals uh, for practice purpose on helical gear. So problem statement is that two helical gears having gear ratio of 4 and normal module 8 mm with normal pressure angle 20 degree and helix angle 28 degree. If the center distance is approximately 650 mm apart, determine the number of teeth on each gear and the exact center distance. That problem was asked in December 14 examination and August 16 examination for 6 months. Now the given data is normal module. As you know, in case of helical gear, as the teeth are inclined to the axis of rotation, so two different planes are existing in case of helical gear. One is a transverse plane, which is plane of rotation, or this plane is perpendicular to the axis of rotation, and another teeth is normal plane, which is normal to the teeth on helical gear. Okay, so they are, so when planes are, two different planes are there, so two different modules are there, two different downward pressure are there. Okay, one is a normal module, second is a transverse module, and the pressure angle which is on transverse plane, that is a transverse pressure angle, and the pressure angle which is on normal plane, that is a normal pressure angle, phi n and phi t. Okay, so in problem statement, the model which is given is a normal model, 8 mm. Okay, so mn is given 8 mm, and normal pressure angle phi n, pressure angle in normal plane, that is given 20 degree, and helix angle which is denoted by alpha, that alpha is given 28 degree. Okay, then if center distance is approximately 650 mm apart, we have formula for center distance. Center distance approximate is given 650 mm. Okay, and gear ratio is given 4 mm, that is nothing but g, gear ratio, velocity ratio, or speed ratio, which is a ratio of speed of driver to the speed of driven wheel, where driver is a pinion and driven is gear is a driven. This is our assumption while solving the numericals. Okay, now we have to find out number of teeth on helical gear, that is capital T, and number of teeth on helical pinion, that is small t. We have to find out capital T and small t. Second is exact center distance. So we have formula module is equal to d by t. Module is equal to d by t. In unit 1 also we are studying that formula, in second unit also, in this unit also we are studying that formula. Okay, module is equal to d by t, but this module is which module? This module is no transverse module. Okay, remember that the formula which we have studied, module is equal to d by t. In that case, module is always a transverse module, not a normal module. Okay, it is a transverse module because that module is in, you can see, in transverse plane. So this module is a mt is equal to d by t. So in this case we have to find out capital T and small t. Okay, so for finding the mt, but module, which module is given here? Normal module. Okay, normal module is given, so we have another formula to find out transverse module. When mn is given, at the time mn is equal to mt cos alpha. Mn is equal to mt cos alpha. Remember this formula, and we have already discussed that formula in previous lecture. I will share the link of previous lecture after below the comment box. Okay, so Mn is equal to mt cos alpha. Mn is equal to mt cos alpha. So mt we will find out. Mn value is given, alpha value is given, so we can find out mt. By putting that mt value here, again d we don't know, p circle diameter of gear, two unknowns are there. So we will find the t in terms of d. Small t, again we will find out in terms of small d, okay, from this formula. And by putting the value of capital D and small d in this formula, we can, center distance is given 650 mm, center distance is 650 mm. So putting this value here, and one unknown will be there, so we can find out small d and capital D. Okay, so let us start to solve the numericals. Module Mn is equal to mt cos alpha. I am writing that formula again here. Mn is equal to mt cos alpha. So Mn is given 8 mm. Mt we have to find out into cos of alpha, which is given 28 degree. Okay. So after solving this simple equation, we are getting the value of mt is equal to 9.06 mm. 8 divided by cos 20. So we are getting the value of mt, the transverse module, is equal to 9.06 mm. So putting that value of mt in this m formula, mt is equal to d by t. So d is equal to 9.06 into t, capital T. So what is that d? D is nothing but 2 into radius. This is diameter, p circle diameter. So we are going to find out p circle radius. So d is nothing but 2 into radius is equal to 9.06 into t. So value of p circle radius for gear, capital R, is equal to 9.06 divided by 2. We are getting here 4.53 into capital T. This is equation number 1 for gear. That equation is for gear, capital R and capital T. We are using for helical gear. Okay. But what is gear ratio G? That is given for G is equal to a ratio of number of teeth on driven divided by number of teeth on driver is equal to, what is T2? What is T2? That is number of teeth on driven wheel. What is driven wheel? That is a capital T. Capital T we are using for gear. Okay. So gear ratio is equal to number of teeth on gear divided by number of teeth on pinion. Okay. So putting that value of G here, so we can find out capital T. Capital T is equal to 4 into small t. Okay. Putting that value capital T in this equation, so we are getting that R is equal to, in this first equation, R is equal to 453, 4.53 into 4 into T. What is the capital value of capital T? That is 4 into small t, that is getting for gear ratio formula. Okay, so the value of capital R, pitch circle radius for gear, is equal to 18.12 into small t. So from my same equation we are finding pitch circle radius for pinion also by this formula, module is equal to d by t. What is module here? We are getting 9.06. Module is equal to mt is equal to 9.06 is equal to small d divided by small t. We are using the small d and small t for pinion. Okay, so d is equal to, small d is equal to module into small t, 9.06 into small t. So 2r, we are finding pitch circle radius. half of 9.06. So R is equal to 4.53 into small t. That is equation number 2 for pinion. Okay. So now we have found out small and small r and capital R. Small r and capital R. We will put these values small r and capital R in center distance formula. Okay, because center distance, value of center distance is given, approximate center distance is given. So putting that value, only one unknown is there, that is small t. So center distance is equal to small r plus capital R, where center distance, approximate center distance is given 650 mm is equal to small r is equal to capital R is equal to, here capital R is equal to 18.12 into t, 18.12 into t, and small r is equal to 4.53 t, value of small r 4.53 into t. So only one unknown is there. After solving this equation, we are getting the value of small t is equal to 28.69. But this is decimal value and number of teeth will be a complete value, okay, integer value. So rounding off this number, we are getting 29 teeth. Okay, so putting that value 29 in gear ratio formula, gear ratio formula is equal to G is equal to capital T by small t. So capital T is equal to 4 into small t, G. So putting that value of 4 into small t, we are getting the number of teeth on gear is equal to 4 into 29. We are getting 116 teeth. So these are the first solution of question number 1, number of teeth on pinion and gear. Okay, now exact center distance. Exact center distance. What is exact center distance? Center distance is equal to small r plus capital R, or small d plus capital D divided by 2. But I am writing that d in terms of module. Okay, module is equal to d by d. So what is d? Module into number of teeth. Transverse module into number of teeth. So transverse module into number of teeth, 9.06 into capital T 116 plus module into small t, 9.06 into small t. Value of small t we found out here 29 divided by 2. Small d plus capital D divided by 2. Here by solving this equation, we are getting exact center distance is equal to 656.85 mm, which is the solution of second question in this equation. So these numericals are very simple, which will compulsory come in the examination. Okay, just you have to taking the values and putting in the equation, and you are getting the answers here. Okay, so don't skip that numericals on helical gear in the examination, because these are very simple numericals. So try to practice number of numericals from question bank. Okay. Now the second numerical is, second sum is the problem statement for second numerical on force analysis. Already in previous session, we have discussed the different forces which are acting on helical gear. Okay, radial force, trans tangential force, and axial force, Fa, Ft, and Fr. Okay, on these formulas and a resultant force, on these formulas this numerical is based. Okay, so two helical gear are used to transmit 150 kilowatt power with the velocity ratio of 3:1 in between parallel shaft. The normal pressure angle, that is phi n, is given 20 degree, and normal module mn, m suffix n, is given 12.5. The pinion has 20 teeth and rotates at 600 rpm. That means small t is given, small t 20, and np rotational speed is given for pinion 600 rpm. Helix angle is 30°. Determine the center distance, first one. Second, the axial thrust on the gear. Third, the transverse pressure angle. And fourth, we have to find out normal tooth load. So given in this statement is normal module. Okay. In problem statement that is directly mentioned, normal module is 12.5 mm. Okay. Pressure angle, normal pressure angle is 5n is equal to 20°. 20° normal pressure angle. Velocity ratio or speed ratio or gear ratio, that is denoted by G, is given 3:1. So value of G is given 3. Okay. Now next data is given helix angle. Helix angle for helical teeth is given 30°, which is nothing but alpha. Okay. Power is given P 150 kilowatt. After conversion, that kilowatt into watt is equal to 150 into 10 raised to 3 watt. Okay. So teeth on pinion, that is small t, is given 20 and MP is given 600 rpm, and we have to find 4 values. Okay, in the problem statement is center distance. Okay. Second thing, axial thrust on gear, that means we have to find out FA, axial thrust, axial force. Third one, transverse pressure angle, phi t. Okay. And fourth one is normal to the load, that means you have to find out capital F. Okay, we have this formula gear ratio again on capital T by small t, and gear ratio is given as 3:1. That means speed of driver to the speed of driven. Okay. That is given 3. So capital small t is value of small t is given 20. So only one unknown is there. So we can find out capital T is equal to gear ratio 3 into small t, which is given 20. So value of capital T, number of teeth on gear, we are finding here, we are getting here 60. Okay. Now the second formula we have, Mn is equal to Mt cos alpha. So Mn is given 12.5 and Mt we have to find out, because in module formula, in this formula M is equal to d by t, that M is nothing but transverse module. So but in question normal module is given, so from normal module we can find out transverse module with this formula Mn is equal to Mt cos alpha. So putting the values of Mn and helix angle, which is 30°. So 12.5 divided by cos 30 is equal to Mt. So we are getting the value of Mt is equal to 14.43 mm. Okay. So putting the values of 14.43 in this model formula into capital T, that we got here 60. So capital D we are getting here 865.8 mm. So that is the pitch circle radius for gear, pitch circle diameter for gear. So from diameter we can find out radius is equal to half of 865.8 is equal to 432.90 mm. That is pitch circle radius for helical gear. Now pitch circle radius for pinion, that again we can find out with this formula. Mt is equal to small d by small t. Mt 14.43 we are getting from this formula, 14.43 into number of teeth on pinion, which is given is 20. Okay, so multiplication of this we are getting 288.60 is equal to, that is the pitch circle diameter for pinion, helical pinion. From this we can find out pitch circle radius for helical pinion is equal to half of 288.60 is equal to 144.30 mm. So center distance is equal to small r plus capital R. Small r plus capital R. And center distance is the addition of this, we are getting the value of center distance is 577.20 mm. This is our answer for first question, center distance. Now second, axial thrust on gear, FA. Axial thrust on gear, FA is equal to, we have formula FA is equal to FT into tan. Axial force is equal to tangential force into tan alpha. Okay, Fa we have to find out. We don't have tangential force value, but we have alpha. Two unknowns are there, so we can't solve this equation, but we have formula for Ft. Tangential force is equal to torque divided by R. Torque. But torque is also not given, but that torque is given in terms of power. So we have formula that you learn in first year engineering mechanics. Power is equal to 2 pi nt. Okay. When you are taking power in watt, at that time, that speed, rotational speed and speed rpm, you have to convert in rps, revolution per second. At that time your answer will come in watt. Okay, so power is given 150 kilowatt, so I'm converting that in watt multiplied by 10 raised to 3. 150 into 10 raised to 3, that will come in watt, is equal to 2 pi n is given 600. As this 600 rpm, that 600 rpm I will convert in rps, so divide by 60. So it will come rps. That conversion you have to do properly in examination also, because conversion is, if you make mistake in conversion, your final answer will come wrong. Okay. So 600 divided by 60 into torque. So after one unknown is there, only torque is unknown. So after simplifying this equation, the value of torque we are getting here 2387.32 Newton meter. Okay, Newton meter. I convert this in Newton mm by multiplying 10 raised to 3 Newton mm. Okay. Why I am converting this? Because this R we have in mm, radius in mm. So that torque also I will convert in Newton mm. So Ft value, putting that value of torque here, 2387.32 into 10 raised to 3 divided by R value is given, this circle radius. We just find out here smaller is equal to 144.30 mm. Here we already found out R 144.30. Putting the value of R here 144.30, we can find out Ft. So the value of Ft is getting here 16,539.93 Newton. Okay, convert this by dividing 1000, we are getting the value of Ft in kilonewton is 16.539 kilonewton divided by 1000 to this value. So putting that value of Ft here, Ft in this equation, alpha you know, only one unknown is there, so we can find out Fa. Fa we are getting 16.539 kilonewton into tan of alpha 30. We are getting 9.549 kilonewton. Okay, actual. So we are getting the second solution of problem which is given in question. And third value that we have to find out is normal tooth load. That is nothing but capital F. So we have formula Fr is equal to F into sine phi n. But we have to find out F here. Fr is also unknown. Two unknowns are there, so we can't use this formula. For finding the value of Fr in this formula, we have the formula Fr is equal to tangential force into tan phi t. I will share the link of this session in which we have all derived these formulas. Okay, so Fr is equal to Ft. Ft we have already found out. Tan phi t is given. No, phi n is given. Phi n is given. So phi n is given. This is again unknown. Fr is again unknown. So two unknowns are there. So we have to first find out phi t. So for finding phi t, we have this formula. Tan phi n is equal to cos alpha into tan phi t. You can see here, already discussed in previous session, tan phi n is equal to cos alpha into tan phi t. Tan of normal pressure angle is equal to cos of helix angle into tan of transverse pressure angle. Tan phi n is equal to cos alpha into tan phi t. I'm using the same formula here for following the numericals. We have to find out phi n. Phi n is given. Alpha we know. Only we have to find out phi t, tan phi t. Okay, tan phi t is equal to tan phi and tan of phi n is given 20 degree normal pressure angle divided by cos of helix angle is given 30 degrees. So tan phi t is equal to 0.4202. We are getting here. Okay, tan phi t. So putting the value of tan phi t in this equation, and value of ft we have already found out. Okay, so putting the value of ft and tan phi t, ft value of ft is equal to 16.539 kilonewton. Okay, so putting a 16.539 kilonewton into this tan phi t is equal to 0.4202. We are getting value of fr radial force is equal to 6.95 kilonewton. So putting the value of 6.95 in this equation, fr 6.95 divided by sin phi n. Okay, so f is equal to fr 6.5 divided by sin phi n. Phi n is given, tan of phi n is given here, phi n 20 degree. So sin 20, we are getting the value of at normal tooth load, f is equal to 20.32 kilonewton. This is our solution for question number 3. And fourth question is asked here, transverse pressure angle phi t. Already we have equation here, tan phi t is equal to 0.4202. So tan phi t is equal to tan inverse of this value. Tan phi t is equal to this. So phi t is equal to tan inverse of this value. So tan inverse of this value is equal to 22.80 degree. 80 degree. Okay, so these are simple numericals that in which you have to directly putting the values by conversion, and you are finding the a solution of given question in the problem statement. And this question compulsory asked in the examination, so don't make mistake in putting the values, don't make mistake in conversion. Okay, so you will get the exact answers. Okay, 6 marks in your hand if you practice some 2 to 3 numericals for getting the confidence in the examination. Okay, so at the end of this session, you can solve, you can understand the numericals, and you can solve the numericals on center distance, power, and the different forces which are acting on vehicle here. Thank you so much for attendance.